Let's review the definition of a logarithm. Before we review the definition of a logarithm, let's refresh our memories on what we do with the negative exponents here. For instance, 2 to the negative second. Remember that negative exponent means that we flip and change the sign on the exponent. So 2 to the negative second becomes 1 divided by 2 squared, which ultimately is 1/4. And hopefully you can fit that in a little bit better than me. 2 to the negative first, we flip and change the sign on the exponent. It becomes 1 over 2 to the first, and we don't even really need to write the 1. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 2 times 2, which is 4. 2 cubed is 2 times 2 times 2, which is 8. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. And 2 to the 5th is 32. The reason I put those there is because if you did take Algebra 2 last year, we had little mini pieces of paper that we did on a daily basis. And one of the things that we had in there was logical arithmetic. Let's get ready to do that in Algebra 2 also right now. So the question is, if 2 to the x equals 16, what does x equal? Well, we can look up above there and we see where we found 16. So if we work backwards there, what we see is that x is going to be 4. Now we don't have 2 to the x equals 64, but can we figure it out? In other words, what we're asking is, what exponent that we put on 2 is that going to give us get 64? Well, the exponent that it's going to give us is just one more. Had I had space to put it in there, I would have. It should be 2 to the 6th. And if you're unsure of that, go to your calculator and try 2 to the 6th. And sure enough, it equals 64. But this third one here, I do have, it says, if 2 to the x equals 8, well, what does x equal? When we look above there, we see that x equals 3. And when we're doing the logical, or when we did do the logical arithmetic in Algebra 2, and as we look at it here today as well, what we're really looking at is we're really looking at logarithms. I capitalized the A because there's a syllable there, logarithm. I don't pronounce it as well as I should, but I'll emphasize it there. Logarithm base 2 of 8, or it could be written as log base 2 of 8, is asking, with base 2, what exponent gives you 8? And we just found out, because 2 to the 3 equals 8, our exponent must be 3 in this case. So there's a little background here before we get into the logarithms. But the first sentence there is probably the most important. Logarithms are another way to write an exponent. That's all it is. So we see this big word logarithm. We're like, oh no, this is going to be so hard. But if we can work with exponents, we can work with logarithms. And the abbreviation for logarithm is log. Number 2, we have an exponential equation that says n equals b to the p. We have a logarithmic equation, log base b of n equals p. These two equations are equivalent. It's EQUIVALENT. They're equivalent. They mean the exact same thing, whether we write it with the word log or we write it as an exponent. And I've already alluded to it as we've been talking about these problems here. How do we read these phrases or equations? It's log base b of n equals p. Log base b of n equals p. Same kind of thing in problem number 4. It's log base 2 of x equals y. There's actually two kinds of logarithms. There's a logarithm called a common logarithm, and a common logarithm has a base 10. We can write a common logarithm as log base 10 of x, but we don't really need to write the 10. We simply can say that this is log of x. Without showing the 10 is understood. The other type of logarithm has a base of e, and it's called a natural logarithm. It's abbreviated as ln. In other words, log base e of x equals the natural log of x. And if I pull up the calculator here for a minute, just to point out that the log button is to the far left of your calculator. It says log, and it's base 10. Right underneath that is the natural log button, the ln button, just to show you where those are as we get throughout this unit. We'll want to know that. So let's take a minute and practice writing exponentials in terms of logarithms. And you can look back at number 2 here on our exponential and logarithmic because they're the same format. I used the same letters. But the thing that I want to stress the most is a logarithm is another way of writing an exponent. So when we see the exponent up here on these particular types of problems, it's what the logarithm equals. The exponent on problem number 1 is 4. So our logarithm, regardless of the rest of the stuff, equals the exponent. Well, this is 3 to the 4th. The 3 is a subscript. It drops down a half a space. It's kind of like an exponent, only you go downward instead of upward, which means that there's only one more piece of the problem, which is the 81. This is log base 3 of 81 equals 4. And we're just spending a couple minutes practicing rewriting these exponentials as logarithms. But once again, a logarithm is another way of writing an exponent. So whatever the exponent is in the problem is what this logarithm equals. Log, our exponent's -2. And it happens that our base is the 4. It's going to drop down a little bit. And then we have our 1/16. Log base 4 of 1/16 equals -2. Problem number 3, still the same idea. Whatever the exponent is what the logarithm is going to equal. In this case, we've got 2/3 cubed. It's on the right side, but the exponent is still what the logarithm equals. The 2/3 is the base of that. That's where it's going to drop down here. Log base 2/3 of 8/27 equals 3. We can write an equation that's an exponential. We can turn it into a logarithm. We can go the other direction as well. And here, even before we start the problems, you can see how we drop down with that 5. Log base 5. See how the 5 is a subscript. It drops down. It kind of looks like an exponent. We went down instead of up. When we rewrite this, in this particular problem here, remember that what the logarithm equals is the exponent. So it's log base 5. The exponent on the 5 is going to be the 3, because that's what the logarithm equals. 5 cubed equals 125. Problem number 2. Log base 9 of 3 equals 1/2. What the logarithm equals is the exponent. Log base 9 to the 1/2, because that's what the logarithm equals 3. The 1/2 is the exponent. The 3 in the first problem was the exponent. Over here in number 3, the exponent's going to be 5. And we need to know what the base is on this natural logarithm. And hopefully you remember from just a minute ago that's an e. So if we write this in exponential form, it's going to be e to the 5 equals x. And just as an aside here, I want to show you how to type that into your calculator. The E button is on top of the natural log button. If you have the Inspire, it has its own button. But we're going to go second, E, and then I think our exponent was 5 in this particular problem, and it was. So I did second ln, that brought us up to the E function, and then when we type it in, we get the 148.413 if we round it to the thousandths. And I know that that problem did not ask you to do that, but on your practice, you're going to have to do that, so I wanted to show you where that was. The key element really at this point in time is, do you know that the base of the natural logarithm is e? That's the question. As we keep moving here, we can find the value of a variable in a logarithmic equation of log base b of x equals y if we know 2 of the 3 pieces. 2 of the 3 variables are known. And the best way to solve logarithmic equations is to rewrite the logarithm as an exponential. I lost the letter there. E-X-P-O-N. Sorry, I know that's spelled wrong. But I don't know. E-N. I'll get this right. E-X-P-O-N. Exponent. E-N-T-I-A-L. Better. Exponential. And then use our exponential rules. Our exponent rules. So when we look at problem number 1, I wish that I would have put it a little bit farther here in our examples. But natural log of x equals 3. We just saw one like this. And the key part here is knowing that the base is e. So that's a lot of e to the x equals 3. You don't necessarily have to write it, but if we want to solve this, we're going to write e to the 3 equals x. And on this one, our directions say leave answer in simplest fraction form if necessary, but on the practice it says round to the nearest 10,000. So once again, on our calculator, where we would go is we would say second ln. This time we're going to type in the 3. And we press enter. So we get 20.0855. But this second 5 right here is going to cause us to round up this 5 in front of it. So this is going to become 20.086, because if that number is 5 or higher, we round up. And we end up with 20.086 equals x. Even though I don't have that on the directions, I have it on the practice. Number 2. Log base 9 of x equals 3/2. Rewrite the logarithm as an exponential, and remember that what the logarithm equals is the exponent. So it's going to be 9 to the 3/2 equals x. Now I know some of you are going to go and just type this in to your calculator, and I'm not going to make a big deal out of it. But just keep in mind, we still need to know what to do when we can't type it in our calculator. So what we're going to do with the rational exponent, a fraction exponent, is we're going to rewrite this. The base is 9. The denominator goes in the check mark part, and technically we don't have to write that 2. And our numerator is the power there. So ultimately what this is asking here is, what's the square root of 9? That would be 3. And once we figure out that value, then we need to cube this. And 3 cubed is 27. Again, I know that some of you are just going to type in 9 to the 3/2. Keep in mind, there's going to be a time where you might need to know that definition. So it's good to practice it a little bit so we know it later on. Logarithm is another way of writing an exponent. But what we want to do is we want to convert this to an exponential. So this is going to be x to the 1/2 equals 5. Speaking of, what do we do when we can't type this into our calculator? Well, we need to convert it. And what we do to convert, once again, is that the base is the radicand. The denominator is the index. It goes in the check mark part, but the 2 doesn't have to be written. The 2 just indicates square root, and we don't have to have a symbol for square root in there. And this equals 5. Well, we want to solve it. We want to figure out what does x equal. So we need to know that the inverse operation of square rooting is squaring. So we're going to have to square both sides. So we end up with x equals 5 squared, which is 25. Number 4. Rewrite this with an exponential. B to the 3 equals 64. So what we're asking ourselves to do on this problem is, what times itself 3 times equals 64? And again, if you think about your quick recall, then you might remember this from Algebra 2. But if you don't remember how to do it from Algebra 2, remember that the opposite operation of cubing something is going to be to cube root. And if we cube root the left side, then we need to cube root the right side. So once again, if that's confusing, figure out what number times itself 3 times gives us 64. And by the way, if you need to remember how to type this into your calculator, the way we type it in is we go to Math, Function 4, and 64, and we come up with the answer of 4. So B equals 4. 4 to the third power equals 64. The last 3 are evaluating problems. And the thing about evaluating is that we don't have an equals in them. However, there's nothing saying that we can't put an equals in them. And typically when I put an equals in here, I usually say equals P. If you had Mr. Graham, he puts equals E. If you want to put the first letter of your name, put that. It doesn't make any difference, because what we're trying to figure out is what power do we raise 5 to get 625? Or in other words, 5 to the P equals 625. Now this one is a little bit wacky, but we could, in our calculator, we could type 5, we could go 5 times 5 is 25, times 5 is 125, times 5 is 625. If we need to figure that out. But another way that we can look at this problem is we can break this down. It's 5 times 125. And break this down again, like I was just saying, and break this down. So we can rewrite 625 as, we still have our 5 to the P over here, equals 1, 2, 3, 4. 5 to the 4th. Well, ultimately, when we solve this, what we have is we have a 5 on the left side and we have a 5 on the right side, but they're already the same. So the only thing that we need to be concerned about are the exponents. And sometimes what we do is we cross out the 5s. They don't really cross out. But if that helps you get the correct value, then we should use that technique. Once again, set this equal to something. I know that it doesn't have an equals in there. I tend to put equals P. Some people put equals X every single time. It's fine. Rewrite this as an exponential. 2 to the P equals 64. And once again, if you don't know what that answer is, and we did go through the 2's here on the front of the paper, but remember 64 is 8 times 8, which is 4 times 2, which is 2 times 2, and another 4 times 2, and 2 times 2. Ultimately, what we get here with 2 to the P equals 64 is it's 2 to the P equals 2 to the 1, 2, 3, 4, 5, 6. And we've got a 2 here that we don't need to worry about because it's the same as the 2 there. And we end up with P equals 6. Finally, with log base 2 of 1/16. A little bit tougher because we have a fraction here, but hopefully not too tough because we know our values of 2 for the most part. We can rewrite this as an exponential. 2 to the p equals 1/16. Let's rewrite 16 in terms of 2. It's 4 times 4, and 2 and 2, and 2 and 2. So this becomes 2 to the p equals 1 over 2 to the 4th. Well, our previous 2, we were able to get it into 5 to the p equals 5 to the 4, and 2 to the p equals 2 to the 6. We don't quite have it in that format, but if we use our knowledge of exponential rules, what's going to happen is, if we take 1 over 2 to the 4th and we flip it, what's going to happen is we can change the sign on our exponent. And when we do that, yet again, we've got a 2 here and a 2 there that we don't need to be super concerned about. And we end up with p equals -4.